For months, astronomers had been watching an unusual visitor moving through our solar system. At first, there seemed to be nothing extraordinary about it. It was simply another fast-moving interstellar object passing through a region of space that humans could only observe from a distance. But then the observations became more interesting. The object, known as 3I, Atlas, appeared to be moving at an incredible speed as it traveled through the solar system. Its unusual origin alone made scientists curious, because objects arriving from outside our solar system are extremely rare. What happened next created even more questions. As researchers continued tracking its movement, attention turned toward Mars. Updated calculations suggested that the object could pass relatively close to the red planet. On the enormous scale of space, even millions of kilometers can represent a remarkably close encounter. That raised an obvious question. Could 3I, ATLAS actually collide with Mars? A collision between an object of significant size and Mars would be an extraordinary scientific event. It could create a huge impact crater, throw material into the Martian atmosphere, and potentially alter the surface around the impact zone. But the real mystery isn't simply whether an impact could happen. It's the behavior scientists are trying to understand. Comets and other icy bodies can release gas and dust as they approach the Sun. Those emissions can produce small changes in their motion. In astronomy, these effects are known as non-gravitational forces. Normally, such changes can be explained by natural processes. But imagine an object whose movement changes enough to make scientists repeatedly update its predicted path. Suddenly, every new observation becomes important. Could the object simply be behaving like an unusual comet? Or could there be something else happening? Some researchers and commentators have suggested extraordinary possibilities, including the idea that an interstellar object could be artificial. However, such claims remain speculative and require far stronger evidence than unusual movement alone. Still, the possibility is fascinating. Imagine an object traveling between stars for millions or even billions of years before entering our solar system. It could have formed around another star, survived unimaginable distances, and eventually passed close enough to become visible to our telescopes. We would be looking at something that originated far beyond our planetary neighborhood. And Mars makes the situation even more intriguing. Mars has been one of humanity's biggest targets in the search for clues about ancient environments and possible life beyond Earth. Rovers and orbiters have spent years examining its surface, atmosphere, rocks, and underground regions. So if a large interstellar object were ever to strike Mars, scientists wouldn't just be watching an explosion. They would be watching a natural experiment on a planetary scale. Material from deep beneath the Martian surface could potentially be exposed. Ancient geological layers could be disturbed. Dust could spread through the atmosphere. And instruments already studying Mars could provide scientists with an unprecedented amount of information about the event. But there is another reason researchers would take such an encounter seriously. If an interstellar object contains unusual organic compounds, studying those materials could help scientists understand how chemistry develops outside our solar system. Organic molecules are not automatically evidence of life. They can form through completely natural chemical processes. Yet finding unfamiliar compounds on an object from another star system would still be incredibly valuable. It could provide clues about how planets and small bodies form elsewhere in the galaxy. And that brings us back to 3I, Atlas. Every observation gives astronomers another opportunity to calculate its trajectory more accurately. The more measurements they collect, the more precisely they can determine where the object is heading and how gravity and natural outgassing are influencing its path. That is why even a tiny change matters. A small adjustment in velocity can eventually produce a much larger difference in position after millions of kilometers of travel. From our perspective, an object may appear to be following a simple line. But in reality, its path is constantly being shaped by the gravity of the sun, planets, and other forces. This is where the story becomes genuinely fascinating. Space can make an ordinary physical process look mysterious. A jet of gas escaping from an icy body can slightly change its motion. A gravitational encounter can bend its trajectory. A new observation can change the predicted location. And when all of these effects are combined, the final path can look dramatically different from what was predicted earlier. For scientists, that doesn't automatically mean something artificial is controlling the object. It means there is still more to learn. And that uncertainty is exactly what makes an interstellar visitor so important. If 3I, ATLAS passes Mars without incident, it will still leave behind something incredibly valuable: data. Scientists will be able to compare observations from different telescopes, study its composition, examine its behavior near the Sun, and improve our understanding of objects that originate outside our solar system. But if future observations reveal something truly unexpected, the story could become much bigger. Because for the first time, humanity would have the opportunity to closely study material, but the mystery surrounding 3I, ATLAS doesn't end with its trajectory. If anything, the closer astronomers look, the more interesting the object becomes. One of the most important things scientists can study is what happens when an interstellar object approaches the Sun. As the object gets closer, heat from the Sun can cause frozen materials beneath its surface to turn directly into gas. That gas can carry dust and other particles away from the object, creating the bright cloud and tail that make comets visible from Earth. For an ordinary comet, this process is already fascinating. For an object that originated around another star, it becomes even more important. Why? Because its chemical composition could preserve information about the environment where it was born. Our solar system has its own chemical history. The planets, moons, asteroids, and comets contain different combinations of elements and compounds that formed during the early development of our planetary system. An interstellar object could have a completely different chemical fingerprint. That means every observation of 3I, ATLAS could potentially answer a much bigger question. Are the ingredients used to build planets similar throughout the galaxy? Or does every stellar system create its own unique mixture of materials? This is one reason powerful observatories are so important. Telescopes don't simply take photographs. They can analyze light. When light passes through or reflects from material around an astronomical object, certain wavelengths can reveal the presence of specific molecules and elements. Scientists can then use those patterns to build a chemical picture of what they're observing. If unusual gases or organic compounds are detected around an interstellar object, that doesn't automatically mean life is involved. But it could tell us something about chemistry beyond our solar system. And chemistry is where the story becomes especially interesting. Some of the basic molecules associated with life can form naturally in space. Carbon-based compounds have been detected in many different environments, including clouds of gas, meteorites, comets, and planetary atmospheres. So finding organic material wouldn't prove that 3I, ATLAS carries life. Instead, it would raise a different question. How common are the chemical ingredients necessary for life across the galaxy? If those ingredients are widespread, perhaps the conditions that eventually lead to biology may also be more common than we once believed. But there is another possibility scientists have to consider. What if the unusual behavior of the object can be completely explained by natural physics? That may sound less exciting, but scientifically, it could be just as important. Every strange observation gives researchers an opportunity to test existing models. If an object behaves differently from what a model predicts, scientists don't immediately abandon physics. They investigate. Maybe an overlooked source of outgassing is responsible. Maybe the object's shape is unusual. Maybe its surface contains materials that react differently to sunlight. Maybe its rotation is affecting how gas escapes. Or perhaps several small effects are combining to create the unusual movement. The universe has a habit of producing strange phenomena without requiring an extraordinary explanation. And that's why scientists have to be careful. A dramatic theory can be exciting. Evidence is what matters. This distinction becomes especially important when discussing the possibility that 3I-ATLAS could be artificial. The idea of an alien probe entering our solar system is fascinating. But extraordinary claims require extraordinary evidence. An unusual trajectory isn't enough. A strange chemical signature isn't enough. Even unexpected changes in brightness aren't enough. To seriously demonstrate that an object is artificial, scientists would need evidence that natural explanations cannot reasonably account for. That could include unmistakable technological signatures, controlled movement inconsistent with known physical processes, or another form of evidence that clearly points toward engineering. Until then, the artificial object hypothesis remains speculation. But speculation can still be useful when it motivates people to ask better questions. And there is one question that deserves serious attention. What would happen if humanity eventually discovered an object that really was artificial? Would we recognize it immediately? Would we know what to do? Or would we spend years arguing about what we were seeing? Humanity has never faced such a situation. Every spacecraft we've launched so far was built by us. Every artificial signal we've intentionally sent into space came from Earth. An object arriving from another stellar system would completely change that equation. For the first time, we wouldn't be sending something into the unknown. Something from the unknown would have come to us. And Mars would be one of the most interesting places for such an encounter to happen. Mars already has a huge collection of human-made spacecraft operating around it or studying its surface. Orbiters have mapped the planet. Rovers have traveled across ancient landscapes. Landers have measured the atmosphere and underground environment. Together, these missions have transformed Mars from a distant point of light into a world we can investigate in remarkable detail. If an interstellar visitor passed close to Mars, those spacecraft could become extremely valuable observers.